for this question, if a MOSFET with W is equal to 1.9 microohms and L to 1.8 microohms, so micrometers, not ohms, is biased in saturation, it's important, what is the gate to source capacitance, which is CGS? This is what we want to find in femtofarads. We're going to assume the gate dielectric is silicon dioxide with TOX equal to 66.8 angstroms, and this is equivalent to 10 raised to the 10, but then negative 10. So angstrom is 10, negative 10. So let's work this out. We have our CGS, and it's going to be equal to, well, we have 2 over 3, and then we have our C gate. Well, our C gate can be found up here as COX times WL. And our WL, we can just write it as 1.9 times 10 to the negative 6, and then also 1.8 times 10 to the negative 6. I'm just going to omit units for this, just to keep it a little bit simpler. And then we have our COX. Well, our COX is going to be this EOX over this TOX. And our TOX, we know to be 66.8 times 10 to the negative 10. So we're going to replace this with 66.8 times 10 to the negative 10. Now, up top are the EOX. We're going to have to do a little bit of substitution right here. So I'm going to draw an arrow from here. We can see that EOX right here is equal to 3.9 times our E subscript 0. And our E subscript 0 is going to be this right here. So we're going to have 3.9 times our 8.85 times 10 to the negative 14. And so we write it out. It's going to look something like this right here. And this is for the values that we have. Your miles may vary because you might have different values, but this is essentially the equation that we're going to be using. Just change the values. Now that we've understood that, we're going to get the value of 1.7 or 1.17859 times 10 raised to the negative 16. Now we'll go back here just so we can look at our notes. We want this in femtofarads. So what we can do is, remember, femtofarad is 10 raised to the negative 15. So we have to get this to look like that. And well, if we want to just take one off the negative side, we are going to move this over here. So this is going to become 10 to the negative 15th, or we can write this as 1.7859 times a f, or not times, but just f for the femtofarads. So f. And now from here, what we can write is in the answer 1 point, and we'll just round it to 8. So we have 11.8 femtofarads for this problem, and that's how we would go about solving it using these notes linked below the like button on page about 70.